Also, as a reminder, for more Microsoft webcasts, you can visit microsoft.com/webcasts. And again, I'd like to welcome everyone to today's MSDN webcast, Windows Communications Foundation, top to bottom. Today's session is part 14 of 15, Message Queuing. And now, without any further delay, I'm going to turn the floor over to today's presenter, Michelle LaRue Bustamante.
Thank you, Tracy. Welcome, everybody. So here we are again. We have yet another installment of the WCF series. So today we'll talk about queued messaging. And for those who I haven't had the pleasure of meeting online yet, I'm an architect with iDesign, and I'm a Microsoft Regional Director for San Diego. My background is that, at least in the WCF side, I just finished a WCF book called Learning WCF. My code has all been posted to thatindigogirl.com, as you see here. So that will be where you'll go to get the download for any samples that I show in this and other webcasts. I also have another blog where I post other things from time to time, and when they're related to WCF, I usually cross-link in some way. So you might want to keep an eye on that one as well. So today what we're going to talk about is the implementation of queued messaging on top of WCF, and so how WCF leverages MSMQ, or Microsoft Message Queue Server, to support a queued messaging scenario. We're going to talk about how we send messages to a queue, how we receive messages from a queue. We'll talk about the difference between transactional and non-transactional queues, and we'll talk about how to handle delivery failures and where we would like to apply message queuing. I'm expecting that you have experience with .NET applications and that you understand the basics of WCF here. So if you've missed any of the earlier webcasts, remember to go back and view some of those. On my main weblog, DustBlonde, I do have a list of all of the links to the webcasts, and you can replay those webcasts anytime. As for the agenda, we'll start with just an overview of reliability features. We'll then do a quick overview of MSMQ features in case you're new to that. And then we'll talk about specifics for WCF, like the binding support, how we configure the clients and services, how we can require queued delivery if that's appropriate, how we can handle delivery failures, and related features. So let's just start with another revisit to reliability in WCF, and I've talked about this before in the past two webcasts. So in any distributed system, when we start invoking functionality across process and/or service boundaries, machine boundaries, for example, as well, we need to make sure that we have some level of assurance that messages get where they're supposed to go, that the system is always left in a consistent state, that we can overcome any transient problems with network connectivity, and even more important, sometimes that we can overcome absolute failure where machines go down, need to be rebuilt, and/or restarted. So WCF provides several reliability features. We talked about reliable sessions first a couple of webcasts ago, and that was really for overcoming transient failures in the network. And then we talked about transactions in the last webcast this morning, where we talked about how do we leave the system in a consistent state. So how do I make sure that when I make calls to many services and other functionality, that if something goes wrong, we roll back the system. For example, we don't update one database if the other fails, to get updated, and that kind of thing. And that's related to transactional programming. Now, in terms of other forms of reliability and even scalability, durable queued messaging, or MSMQ, with WCF can also improve the reliability of your overall system. So where I might apply reliable sessions to help me with potential hiccups in network connectivity when I'm not queuing, in terms of transactions, I'd want to apply that where it's appropriate for reliability of consistency. But there are places where queued messaging is appropriate, and of course this applies only to one-way calls where I don't get a reply back, because the idea is that I'm going to write a message somewhere durable and potentially be able to kind of balance the load of peak periods by processing those messages when I have the bandwidth on my servers. And then another feature, of course, is that absolute reliability that if the machine goes down, I've actually saved the message somewhere in a durable location, that I can restart the machine and the message is still there and I never lose a message. So MSMQ, or message queuing, can be useful for system availability then in that sense, and it can be useful for when the machine is completely unavailable for long periods of time potentially. And queued messaging can also participate in distributed transactions. So I can actually make sure that a message is played to a queue as part of a transaction. I can also make sure that the message gets ultimately played at the server as part of a transaction, so that if anything goes wrong, we restore the message back to the queue. And then that way, again, unless it's played successfully, we never lose a message. The other thing it gives us, of course, is durable storage, and then the idea of retries when there's a failure, so that you have an attempt to retry playing the message for a certain number of times before it becomes considered a poison message. So, high-level overview of MSMQ. For those of you new to it, obviously there's a lot to MSMQ. There's a lot of ways you can structure creating queues and having queues communicate with other queues and so forth. But just from a very high level, MSMQ version 3 is available for XP and Windows Server 2003. And then MSMQ version 4 is on Vista and 2008. And there are some new features we can leverage with 4 that are interesting. We can access queues either using direct calls to system.messaging, which is an API layer in .NET, but WCF also provides a way to listen on a queue and or write to a queue. And so that becomes actually a more elegant programming model. A couple of things about queues. There are private queues and public queues. A private queue is only on this machine and basically can be useful if you offload asynchronous calls to a location on this machine, but you don't want it to be participating or taking up resources as part of the round trip of the request. So if you look at this example, a client makes a call to a service. Maybe it's on a remote machine. And during that call, what we want to do is log the message, but we don't want that to get in the way of the business functionality and data access that has to happen before we can return to the client. So what we really want to do is just know, hey, successfully write the message to the queue, and then let's get on with it, and then return the response to the client. The queue is just for our sanity. Maybe it's to replay the message if there's a problem processing the XML from the client. Maybe it's to log an activity that took place, and we just want to make sure that as part of a transaction, both the queue is written to and the service does its job. And if the service can't do its job, maybe we don't write to the queue. And then, of course, ultimately, a separate service called the logging service might listen on the queue to pull messages from it in order to write to a logging database or something like that. So a local queue could be used on the same machine, and what that means is that you're writing to a durable store on this machine, and then in terms of playing it back, well, we can either go from queue to queue to another machine or whatnot. When we talk about public queues, those are accessible from remote computers, and those allow you to offload the I/O associated with writing to the durable queue to another machine instead of to this machine. And then that way, let's say your application or web servers only deal with incoming requests, and then you have this other queue for doing other things like generating PDF documents or sending emails or doing a log or something like that. So the idea with public queues, too, is that when a client needs to send a message to a queue on another machine, if that machine is down, as illustrated here by the X, then what will happen is MSMQ on the client machine will generate an outgoing queue that will store the messages and keep looking for the remote queue to be online in order to send them later. So what will happen is while the server's offline, the client can be assured we wrote the message somewhere. And as long as we know we wrote the message somewhere, we can go about our business, and at some point it will get to the server. So the idea is that when the server comes back online, the queue takes over on the client machine, sending it to the remote queue, and of course the service listening on the remote queue will pull the messages and process them accordingly. Now, when it's a transactional queue, this will guarantee delivery so that you can make sure that this is played as a transaction, so meaning the client writes to the local queue as a transaction, so we know it successfully got there and we can guarantee that. And then the queue sends the message from local to remote as a transaction if these are transactional queues. And then ultimately, when the message is played at the service, if the service participates in the transaction, then we can guarantee that. So there's 3 transactions that could occur here, and I just talked about transactions in the last webcast, the point being that if the queue is transactional, WCF can participate in the transaction at each of these 2 layers. And then the layer in the middle is MSMQ to MSMQ to get that message across to the server when it comes back online. So therefore, machines can be offline and restarted, and we can guarantee the message gets there if it's a transactional queue. That's a good thing. Now, those are MSMQ features. As far as WCF is concerned, WCF listen on an MSMQ address, and basically there's a net MSMQ binding that's used to send messages to queues from WCF clients and or receive messages from queues. And then there's another binding called MSMQ integration binding, which is intended for backward compatibility with your pre-existing COM plus queue components. So queued service contracts essentially are intended to be only one-way operations because, of course, you're writing to a queue, you're not going to get a response back. It has to be only for one-way operations. So right now that should tell you, yeah, MSMQ gives me durability, but it gives me durability for things that I won't get a response from anyways, because a one-way operation will not report an exception to me. So all I really want is to know the message got there and that it got there durably. Now, the entire contract has to be one-way operations for MSMQ to work on the binding. So what we need to do is factor our contracts so that our one-way operations that can be queued are on a separate contract. And so we mark our operations with one way. Then we provide an endpoint using net MSMQ binding. So we use the binding shown here, net MSMQ binding. The queue address is prefixed with net.msmq as the scheme. Local queues require you to use the private keyword, but notice there's no $sign. So in traditional MSMQ syntax, you use a $sign to indicate the queue name as part of the queue name, and there's no $sign required for WCF addressing. So just to make sure you're not confused by that. And then a remote queue would use the computer name instead of localhost, of course. Now, you can also require queued delivery, so you can say, listen, this message contract, this contract, service contract, is intended to be used for queued messaging only. And what that does is it forces administrators to deploy the service endpoint on MSMQ binding and only MSMQ binding. If this is a requirement of the application and not something that you can have nice to have, then it's a good idea to program that in by putting that on the service contract. Again, to keep your administrative deployment honest. So those are a couple of things about WCF and message queuing. Let me go ahead and start by giving you a demonstration, though, of how to work with queues. So we're just going to do a simple example here where I have a messaging service like the one I just described. So this service contract has a one-way operation. And inside the operation, all I'm going to do is console write line so that you can see the message arrived. As for the hosting environment, right now it's HTTP. So let's just go ahead and run the application first. So I'm going to actually go ahead and run the host first. And then we'll run the client. And you can see my host sitting there. I'm sending messages. Away we go. That's great. Now what happens if the service is offline? I can continue to send messages, but not if I'm not queued, right? Because what happens is, I'm expecting the endpoint to be there. We're just on WS HTTP binding right now. Now if I had reliable messaging turned on, then I would have some delivery guarantee as long as it's just a network interruption. But if the server actually goes down, that interruption will take too long, and so reliable messaging is not going to suffice in terms of getting the message to the service, because it'll time out before that. So what we really need is a durable guarantee in that case. So what we'll do is we'll change this binding to net MSMQ binding. And I'm going to go ahead and do a custom binding configuration. And in the binding configuration, we'll call it net MSMQ. And I'll create a binding section here. So net MSMQ binding. and we'll give it a name, net MSMQ. And basically, there's a number of settings that we can set here. If it's a transactional queue, then durable has to be true. And if it's, so for example, if it's a transactional queue, there we go. Exactly once delivery can also be used. And let's see what else I care about at the moment. I'm going to look at some of these features later, so let's just leave it at that for now. Now, the other thing I'm going to do is, because I'm not on a domain, I'm going to turn off security, and I'll talk about security in a little bit. So there's my new binding, okay? Just setting up a couple basic things. I'm making this a durable queue with exactly once delivery. I'm using the defaults for all the other features like retries and so forth. And then I'm turning off security because I'm not on a domain, and I'm not going to use authentication to this particular service. So what I have then is a new endpoint that we need to tell the client about. So let's go ahead and start the host without debugging. Oops, I think I was already running. Sorry about that. Oh, I'm sorry. I have a couple of things going on here, actually. My address cannot be HTTP, certainly. Forgot to update that. And so what we'll do is we'll actually have a queue, localhost, messaging. Let me find out the name of the queue again, which, by the way, I have a little bit of code in here to create the queue if it doesn't exist using the system.messaging API. That's just for us, because obviously that would be done ahead of time on your deployment servers. So I'm creating a queue called messaging service queue if it doesn't already exist. So localhost and then private, oops, and then messaging service queue. And that's that. Okay, so we'll go ahead and run that again. And let's go ahead and update the client service reference. So it's got a new endpoint now. The contract should be the same. If we look at the client, I now have an MSMQ binding here. And I have an endpoint for MSMQ binding, looking at the same queue. So let's go ahead and run the client. And we'll send a few messages. Take a look. They're getting there. And let's shut down the server. Continue to send messages. Doesn't look like any exceptions occur. So let's take a look at the messaging service queue. And we'll refresh that, and you can see a whole bunch of messages are waiting to play. So we go back to the application here, and let's run that host. And it looks like it plays the remaining messages. Let's go back to the queue. Refresh. They're gone. Good. Okay, so the idea is that the server is not available. Messages will continue to queue. Now I'm doing this on the same machine. The client and the service and the queue are on the same machine. So of course, the service is just not listening and pulling those requests. But if you imagine that the queue is remote, the client machine would get its own outgoing queue that would hang on to those messages, and then the queue itself would try to send the messages to the remote queue when the server comes back online. So let's go ahead and continue, talk about some more details. Now, if the queue is transactional, there's 3 transactions that take place. The first is the client can write to the queue as a transaction and include it in a transaction, which means if the write to the queue fails or if some other thing fails that I'm trying to do as part of a transaction, then it will roll back the queue. It will not write to the queue unless everything is successful. Then from queue to queue, so imagine that scenario, client machine has a queue sending to the server machine. When the server machine comes back online, that can be played as a transaction. And so that makes a guarantee that the message is never lost, right? Because the client queue will not delete its copy of the message until it knows the message got to the server queue. And then lastly, the service listening to the queue can basically participate in that transaction, and the messages will then play to the service as part of that transaction. So only a transactional queue can make these type of guarantees. Now, in terms of transactions, which I just talked about in an earlier webcast this morning, transaction flow must be enabled on the operations in order to participate in the transaction. So you must allow or require transactions on those operations. And then in terms of the operation implementation, that also must participate in the transaction that comes from the queue. So in other words, the queue becomes the root of the transaction, passing its transaction and flowing it to the WCF service. The WCF service says as if it requires or allows that. And as long as it at least allows a transaction to come forward, then the client transaction will be established for us to optionally join. And then when the operation is actually invoked, each operation gets to decide, do I want to join that transaction or not? And if I say transaction scope is required and there is a client transaction, then I will join that transaction. Otherwise, I'll start my own. If anything goes wrong inside the operation, then what will happen is, of course, the queue will keep the message. And there's a few ways to handle those types of failures, which we'll get into in a little bit. But let's just say the simple example is that if something goes wrong inside set counter or reset counters, then the queue will retain the message by default. And of course, the transaction will roll back elsewhere as well. Transactional queues must be durable. So this is a requirement. And I already showed you that when I set the values. So let's take a look at transactional queues then and go through some examples here. I'm going to shut down this existing example. And let's go to a different one. Okay, so in this example, what I have is a counters service. And if you remember my webcast prior to this where I talked about two counters being separate tables, and basically I've got this contract that supports functionality to update those counters. And if we want to keep them synchronized, then the client would flow a transaction and call these two operations, set counter 1 and 2. Now because these are all one-way operations, and because the get counters is not, I refactored the contract so that this would be supporting MSMQ, and so that this iCounters admin would be able to go on another binding that's not queued. Notice that each operation here is saying I allow a transaction to come from the client, so that means we can participate in a transaction from MSMQ. Now, as far as the implementation of the service, right now we are joining that transaction when we reset the counters, when we set counter 1, and when we set counter 2. And you'll notice that I'm actually dumping out the distributed identifier of the transaction. What that means is, if there is a distributed identifier, if the transaction was flowed across the boundary, we will have a distributed identifier. And that is that. So there's my service. Now, as far as hosting goes, we are on a queued binding. So we've got this endpoint for admin over HTTP and then endpoint for the queued binding over MSMQ. And the binding has a few settings in here that I'm not going to talk about yet. So let's actually just go ahead and run the example and see what happens when there's a problem or not. So I'm going to run the client end service. And it's already called, get counters, reset counters. Let's try and set the counters both to 5. And what you can see here is that on the service, we got a call resetting counter 1 and counter 2, both to 5, each of them with a different transaction identifier. The transaction identifier basically comes from MSMQ. So we've got a distributed transaction identifier for that call. If I try to send a bad message, I'm going to get an exception because we're not allowed to set counter 2 to something greater than 10, so the second call failed. And I'll go ahead and continue, and you see I get the error again, continue. So basically, counter 1 was reset, counter 2 was attempted to be set twice, and now we wait for a retry. So there's a way to configure how many times will we try again. So here we are again. I'm going to continue, and we got another retry. So we've reset, or tried to reset, counter 2 again. So that message has now been played 4 times after the original. And that's MSMQ sending the message essentially to the service. And then here we are again. It's trying again. So the question is, how many retries do we get? And this is something that we'll talk about in a bit more detail, but I did configure that here, that we're going to have a max retry cycles of 2. We're going to have a retry count of 1, so we try once and then we try again during each cycle. And then the retry cycle delay was 15 seconds. Now eventually, the message itself will actually expire based on time to live settings for the actual message. But let's just take a look at what happened in terms of the queue itself. So let's look at the message queue. This is the counters queue, and we'll refresh. And there's still a message in there waiting to play. The retries have already happened, in fact, and so until the message itself expires and moves over to the dead letter queue, which is what's going to happen eventually. These I can purge because they're from previous examples. Okay, so the counter, I still have a message waiting to play. And in the meantime, what's happened is the retry cycles have completed, and if I try to actually close the service, you're going to see an exception. And the reason is that by default, what will happen is the message, when retries have been exhausted, will actually fault the channel. So you have to, it'll fault the service host, you have to restart the service host. Clearly, that may not be the desirable behavior, but the only choice you have with MSMQ3 is to either fault like this so that you at least know it happened, or you can drop the message, which means you lose a message. And we don't like the idea of losing a message, so we really need to fault, pick up the fault, restart, and then do something about that bad message. So pull it from the queue using some utility, administrative, and then inspect why it failed. I'm going to talk a little bit more about that in a moment. So the point here is that we've done a couple of things. The client wrote a message to the server queue, and actually what I'm going to do is run the host without debugging so we don't see all of those messages just yet. Then go back to the client application and discuss the first transaction. Okay? So the first transaction here is that I'm going to try and reset both counters together as a transaction. If I write this as a transaction and something goes wrong setting the second counter, or let's say I had some other functionality in here, do something else, and that do something else, happens to try to update a database or do something, and that turns out to be an exception. So I'll just go ahead and leave this as not implemented, right? It's just going to throw an exception, in other words. Something happens in here, throws an exception, we're not going to complete the transaction on the client. So what we should see is that the counter are both, those messages will not end up in the queue. So let's take a look at the queue again. And again, we're going to actually purge this right now so we can start fresh. Okay. And so the queue is empty at the moment. I'm going to go ahead and run the client. Oops. And the client will try to set those two counters as a single call. I get an exception. We go back to the queue, take a look what's in there. There's nothing there. So basically, because these are both part of a transaction, we don't get to see it. And that's because there's an exception. Now what happens if we get rid of the transaction? So let me actually stop debugging. And we'll get rid of the transaction scope and we'll run it again. Client application will try to set both counters, calling the queue, without a transaction. An exception will happen. We go back to the queue, and there we are, 2 messages waiting to play. Now, of course, the intended result would have been that both counters get updated. So if the exception happens somewhere in the middle, then we're going to have a different problem because counter 2 won't even get a message. In other words, it's hard to coordinate which part of the transaction somewhere downstream might fail, and that's why we use transactional programming models. And so if I try to set this to 6 now, what's going to happen is, I'm going to have 1 more message in the queue, but not both. So we're going to leave the system in an inconsistent state. What we prefer is that we roll back so that we either have 2 messages or none. As for the host, I think I might have started actually a different one here. We got resetting counter 1 to 5, counter 2 to 5, counter 1 to 6. And actually, if you're wondering why when I started the host the first time it didn't play those messages right away, it's because the service host was faulted still because we still had that bad message in the queue when I started the host, and so that ended up faulting the host once again. You really have to remove that message out of the queue that caused that was exhausted the retries before the host will work again. So that's why we need to build that in. Okay, so the point here being the client, if it does not use a transaction to write to the queue, then we will not roll back right into the queue when other things go wrong. So we should use a transaction to write to the queue, as we should use a transaction to read from the queue using the service. Now, as for queue-to-queue transactions, WCF doesn't get involved in those. As for service transactions, I already explained that because we're using net MSMQ binding and because the service contract, which I'll show you here again, says I allow transactions, the MSMQ transaction will flow to the service, and because we opt in to join it, we get to participate in that transaction so that messages are never lost. Okay, so in other words, when the host, and I'll start that without debugging again, and I'll start the client once again, and we'll go back to this queue over here, and we'll refresh, make sure we have nothing in there, and I'll go ahead and do a counter reset. We'll get the counters. We see that they've been reset properly. We'll set the counters to something bad that should fail. An exception will happen, as you can see, and if I run over here before 15 seconds, then you'll see there's a retry queue right now involved in trying to replay that message. And in the meantime, there's nothing in the queue. Now, once the 2 retries happen, so we'll see here that retries already happened twice, setting counter 2 to 12, to 12, to 12, to 12, so that was 2 retry cycles. And so eventually, we have no more retry cycles, and we send the message back to the queue, which now faults the channel. So when we try to close the host, you see we get an exception that we cannot use the service host any longer. It has been faulted. We should have picked up the faulted message. Now, if you remember my hosting webcast, I talked about how to intercept the service host event handlers, or the events, so that you could interact with that. Okay. Now, what we'll do is talk about some of these other details in terms of retry cycles and so on. There's a lot of properties available to you with MSMQ binding. You can set exactly once to make sure we get exactly one delivery basically it means MSMQ will track that we only delivered the message once. Durable means that the message will be persisted so that if we restart the machine, we still have the message. And transactional queues are durable. Time to live has to do with the time span for setting the time on the message in terms of how long that message should live before it expires and moves to the dead letter queue. So how long should it, by default it's actually a day, but how long do you want messages to live before they move to the dead letter queue? That's something that you can make a decision. And again, the goal is never to lose a message. So a day seems reasonable if you have an automated janitor that kind of runs around and looks at the dead letter queue every night to see if you had any problems that day. But you might need something more timely, like every hour. And that could also be related to the fact that when messages false, we don't want them to stay there and block the channel. We want to move that out of the message queue so that the good messages can play. Receive retry count has to do with how many times we'll redeliver a message during a interval. So, message doesn't play, exception is thrown, MSMQ will try to replay the message a certain number of times right away. So maybe 2 or something would be sufficient. The default value is actually 5. And then there will be a delay, which is the retry cycle delay, between that and the next retry cycle. So we will wait X number of minutes, let's say. But by default, the value is actually longer. It's about 30 minutes. I'm making it 15 seconds so we can see multiple retries quickly. The max retry cycles is how many times do you want to do retries? So every 30 minutes for how long do you want to retry that before we do something with that message? And again, it's really application specific. How timely should the data be? How are we on MSMQ4? Because if we're on MSMQ4, we have other options for how to get rid of a bad message so that we can look into it. Receive error handling has to do with how do we deal with messages that fail. So after the retry cycles, do we leave the message in the queue, which is what's happening now by default, which faults the channel? Or do we drop the message and then we lose it? Well, I probably never want this. If I'm using MSMQ, it's not nice to have. I want it durable, right? But my only 2 options with MSMQ3 are these 2. So false is the better of the 2, so we never lose a message. The downside is I have to detect the service host has faulted. I have to see the reason why, and I have to make sure that I move that message somehow using maybe system.messaging, and pull that and take a look at why the problem happened by creating some administrative tools to do that. Now, in MSMQ4, we have the option of reject or move, so I'll talk about those in a few minutes. Now, the dead letter queue is a feature that just says whether or not we're using any dead letter queue at all. So do we want to move messages to the dead letter queue if they expire, or just get rid of them? Do we use the system dead letter queue, or do we use custom? And I'll look at that in a few minutes too, because there's an option for MSMQ4 that you can use a custom dead letter queue. All of these features are really related to delivery failure. So the bottom line is a queue can handle failure by either moving the message to another queue or dropping the message altogether. And then in terms of how we handle retries, that's happening with an automatically generated retry queue that you saw. The retries, once exhausted, will put the message possibly back in the main queue or drop it or move it to a dead letter queue or move it to a poison queue. So dead letter queue has to do with really timeouts, but you can use it also to move bad messages that don't play, or you can allow them to move to a poison message queue, which is a separate place where administrators can then look for problems. In terms of the delivery retries, again, we have the retry count. How many times do we retry per cycle? How many times do we do a retry cycle? And what's the delay between cycles? So I'm making, this is a 15-minute retry cycle here. And we're saying that we want to cycle 5 times over 15 minutes, every 15 minutes, to see if we can replay in case the message server was offline. And then, of course, if it goes beyond that, we need to do something. In terms of what to do, what do we do? False, I already explained. This puts it back in the queue and faults the channel. Drop, we lose it. Never want to do that. Move, moves it to the poison message queue, so it's a separate queue from the dead letter queue. And then the dead letter queue is actually part of basically it allows, it's going to be where timed out messages go as well as any messages that were rejected and couldn't play. So that just means that you would need to look at the reason for the failure in order to distinguish the two. The place where we configure this is in the receive error handling. And you can set that to any of these 4 options: fault, drop, move, or reject. If you're using MSMQ4, remember the top 2 are the only ones available to MSMQ3. So we can configure time to live for messages. That would be a way to control how long messages live before they expire and move to the dead letter queue. And that's one option. There are 2 default dead letter queues provided. There's a transactional dead letter queue, and this is the address how to reach it: netmsmq, system, $, and dead transactional. We've got a non-transactional queue, which has a different address for dead letter. Remember that those were the 2 system queues, which I'm going to show you in a moment, back in the component services view, or when we look at the messaging, the message queues, I'm sorry. So these 2 queues are created for you. They're part of MSMQ. And you can just create a service that listens on these queues, and it'll pull the messages from there when there's a problem. You can also do custom dead letter queue, which means you provide your own queue that you've created, and that means we have to indicate we want to use a custom queue. And that would distinguish from other messages that go to the automatically generated queues. Either way, you create a WCF service to listen on this queue or on the default queues, and you're going to have a way to pick up bad messages as they happen. Now, poison messages mean that the message could not replay. It kept on faulting, essentially. And so MSMQ4 creates a poison message queue based on your queue name. So you can actually listen on the poison message queue by providing this address, which is your service and then semicolon poison. Again, you can use system.messaging for all of these things, but with WCF it makes it really easy for you to listen on a bad queue. Or on a queue that contains your dead letter or poison messages. So with that, let's take a look at a couple of these features, and I'll just go through some configurations. So back at our demonstration that we're working with at the moment, we had retry cycles set so that, I was able to show you, if I actually open up the config here, I was able to show you that the the max retry cycles was 2 cycles. Each time we tried to replay the message once, and then the delay between was 15 seconds each. Now, when we send a message from the client, obviously there's going to be a setting for time to live, and the default is a day, if you recall. So I can change that so that time to live is just 1 minute, let's say. And then what that will do is when the message is placed in the queue, its time to live will expire according to this. And that would put it in the dead letter queue if something goes wrong. So what we'll do is run the host again, and we'll run the client. And I'm going to reset the counter, so that'll be a positive result. And so there they are. And I'm going to set it to something bad. So before we continue, let's check the queue and make sure we don't have anything there. Looks like I still have something in retry from before, so I'm going to clear that out. And then let's take a quick look. We've got these two system queues, the dead letter message queue and the transactional dead letter queue. So these are other queues that we want to take a look at, and I'm going to purge so that we have nothing in there just now so we don't get confused. Some of those were just already from delays that we've already created. So I'm going to set the value, and you can see that we tried to set the value to 12, so the second one's failed and already retried once. If I come back to the queue and refresh, you'll see the retry queue has something in it. It's going to try again, and it's going to try, I think, one more time. But 15 seconds only between each. So actually, let's go ahead and refresh. No more in the retry queue. But we do have a message here. And right now it says that it's aborted 3 times, and it's been attempted to move it 4 times from the queue. So it's keeping track. And these are pieces of information we can collect as well. Okay, so eventually this is going to move to the dead letter transactional queue once that minute or so has expired. So we'll just let that happen. And in the meantime, I'll talk about a few other things. But in the meantime, also, remember that the service is faulted. See, I try to close the service, it fails on close because, in fact, the channel is no longer useful. And that's because, by default, the way we were handling problem messages after the retry count was exhausted is the following. So we've got a receive error handling set by default false. Now what if I set that to drop? Then I'm just going to lose the message completely after a failure. So let's go ahead and look again at the queue here. And I've lost my message from the queue, but I should have something in the dead letter queue, and there it is. So that minute expired. And that would be a day by default, remember? And it says that the reason was time to be received has elapsed. So now I have a message sitting there in the dead letter queue that we can, with an administrative tool or service, pick up and process accordingly and figure out what happened. And keep in mind that it actually says how many times it was attempted to be played. Now, coming back to the service, what I've done here is I've changed this to drop messages on failure. So let's run it again. And we'll run the client. And we will reset the counters. And then we'll set this to a bad value of 14, which we know will fail. And of course, the service has tried to set counter 2, it's going to fail. If we take a look, we're going to have a retry queue. And it's going to retry a couple of times. Again, setting it to 14, all these 4 times. In the meantime, now it's probably back, or it will be shortly. So the counter service, there it is, it's gone. That final retry has taken place. But look at what happened. It does not put it back in the queue. And it does not put it in the dead letter queue. We only have that one. Why? Because we said we want to drop messages. Those are the only 2 options, again, that we have with MSMQ3. Now, I can change that, and I can say I want to move it to a poison queue, or I want to reject it. And, so basically my choice is being whether I want to move or reject to go to a poison queue or to go to a dead letter queue. And you can make it a custom dead letter queue, if you like, by doing things like this. So custom, you can say you want to have a dead letter queue, and you want to use custom, and then you give it a URI. And that will tell it, where do I put the message now, if I'm going to reject it instead of move it to the poison queue. So with that, let me actually take down this service, and let's take a look at an example that has a custom dead letter queue administrative service. So what I've got here is a host, and in this host, I have an endpoint for MSMQ. I am rejecting messages, and I'm going to the default dead letter queue in this case. The retry cycle is the same 15 seconds. We're going to retry once. We're going to have 2 retries during a specific sequence. And, just to make sure we're all cleaned up here, remember, I've got 1 item in the dead letter queue already. That's okay. And then I've got no messages currently in the counter service. In fact, the retry queue is empty as well, right? So we're done. Now, the service host is going to run. It's going to try and do the same old thing. The client is going to try and do the same old thing. And actually, just to verify, let's see what our... So, yeah, exactly. And we're not going to let the message time out to go to the dead letter queue. Instead, we're going to let it replay. So notice it's done the first retry, and I'm actually reporting some information here, like the number of times it's aborted and the number of times it's been moved. So you can see my abort count is 012 for each retry. The move count is now 2. And this is the same bad message being sent. Now, just to give you some vision into what's happening at the service, my service is actually, when I receive a message, I'm saying I received a bad message because I'm going to make it a bad message by throwing an exception. And what I'm doing is I'm checking the operation context for incoming message properties, and I'm trying to get the MSMQ properties so that I can actually take a look at things like the abort count, the move count, and so on. So you can actually get information about the MSMQ message properties if it is such a message. Now, let's go back to the console. The retries are probably finished here, actually. And so essentially what I should have, if we take a look again, is I should have another message in the dead letter queue. The message was rejected by the receiver is now my message, as opposed to the message time elapsed. So that's because I rejected it and explicitly said, hey, I want you to go to the dead letter queue. We're not going to be processing that anymore at the server here. But notice my server does not, it can still process new messages, because you'll see I didn't get an exception this time when I shut it down because the channel did not fault. We simply rejected the message. Now what happens when I open up a custom dead letter queue? Look at the config here. I'm listening on the dead letter queue, the transactional dead letter queue. And this time, if a message can't be processed, I want to fault it and put it back in the dead letter queue, because basically what I want is to never lose a message. Somebody's going to have to inspect that thing and see what went wrong. So I'm going to start the dead letter queue host, and it's going to receive a bunch of messages. And you'll see what I got. I got the message, bad message 1. It says the abort count, the move count, what the failure was, which says unknown in this case, delivery status in doubt. Now I can inspect the message further using system.messaging and so forth and find out what was in there, what went wrong, how do I deal with that. And if the message does not play properly to the dead letter queue host, because this code in here could also throw an exception. Sorry, the dead letter queue service. So I've got a dead letter queue service, which implements the same interface, iMessaging service. A couple things I had to do here. I had to set the addressing filter to any so that I could receive any message that was not necessarily directed to this operation. The send message functionality is actually checking incoming properties, getting the MSMQ properties, and looking at the abort count, delivery failure, and then delivery status information. So MSMQ properties has these properties that you can check. Okay? And again, delivery failure, what's in there. You can check if it has a value or not, and you can get the value out. a couple things that you can do there for retries and so forth. And actually, there was something else that I intended to show you here. Just one more second before we go back to the slides to wrap up. And that is on the host here. So what I just went through was, essentially a bunch of these settings related to retry and so on. But I didn't mention security. And I just want to touch on this. I've already had some security webcasts where I talked about security mode between transport and message. And so in this case, for MSMQ, you're typically going to be, again, this is not necessarily interoperable. So if you're just trying to authenticate from your services behind the firewall to your queue, you're probably going to use transport security for that. So what will happen is, and we'll just go ahead and open up this just so you can see what are the settings. The transport settings include an authentication mode. You want to use the Windows domain, meaning that the queues authenticate that way, or certificates. I usually recommend certificates for authenticating with MSMQ, just because it's a stronger authentication mechanism if you need that level of security. And then the protection level by default will be to encrypt and sign messages to get to the queue. And so this is transport level security on the domain. You can also control the algorithms for encryption and so forth, but we won't get into those details. Now, if you're using message security, the reason you might need to do that is because you're passing around Windows credentials in the message, and you want the service that receives the message to look at the username and password, or perhaps look at the issued token from a federated security environment. So you may very well need to have message security support here, which means that you could do both and have transport security for encrypting and signing and certificate authentication, and then you could have message security for the credentials, for example. And so that would be an effective way to authenticate callers are on a valid machine in your environment while still receiving information about the user of the client application and their token in order to process the message. So it really just depends on if the queue is part of the client application environment, or if the queue is really just you having logging behind the scenes and you just want to authenticate with a certificate to make sure it came from a trusted caller and be done with it. So those are just a couple of features about security. Like I said, we already had 2 webcasts on security, and so these are some things that you might want to control. Some other features, too, that you have access to are whether or not you're going to use journaling. And these are MSMQ features that you can control through WCF. Whether or not you're using Active Directory for addressing, whether or not you want to enable tracing, whether or not what kind of queue transfer protocol you want to use in case you want to change it from native protocol to SRMP Secure, for example. So some of this is, again, kind of going into some depths of MSMQ that you may want control over, just to let you know that those things can be controlled through WCF as well. So in terms of when to use queuing, asynchronous behavior, that you want to make sure you never lose a message, guaranteed delivery. Logging is a classic example behind the firewall. And then, of course, any one-way calls where messages are not too large. You're not going to do uploading large files necessarily to message queuing. Today, there are just some limitations, too, with the size that can be supported. But definitely for guaranteed one-way messaging. Another example, and the things I usually see this used for, are behind the firewall, part of my system. I had a call received from a client application, and as part of that XML I received, I need to generate a document, send an email, and so forth. And so what I want to do is make sure that the generation of the document happens on a whole other set of machines and processed during peak loads in a different way. So I would send it to a queue and let the queue be managed elsewhere and offload that from my web server and application server. Same thing for sending emails, let's say, because there could be some peak loads, peak periods to manage. Another thing would be a durable publish-subscribe pattern for notifications if you want to guarantee notifications between machines. So those are some examples of ways you might want to use it. I've got lots of samples in my MSMQ or message queuing directory. If you download my code for the book, thatindigogirl.com has that zip file. And then basically there are some labs also to walk you through that in the book, but I have a number of examples that show poison message queue and so forth, even message security, passing a username password. So take a look at those as well. Let me know if you have questions. And by that, I guess at this point, I'll turn it back to Tracy. Thanks again for taking part in this webcast, and I will take a look at the questions now.
Excellent. Thanks, Michelle. I do want to remind everybody that for more information, they can print a PDF of today's session. And to do that, you just want to go to the File menu in your upper navigation bar. Now is a good time to submit your questions into the Q&A panel. You just want to type them in and hit the Ask button. Also, I'm going to be posting a survey here in just a minute. If you would all please take a moment to fill that out before you log off. We really do appreciate your feedback. As a reminder for upcoming and previously recorded webcasts, you can visit Microsoft.com/webcast. You can go here to access this webcast, which will be available for download in about 24 hours. Now, if you have any webcast content ideas, something out there you'd like to see and haven't yet, we'd love to hear from you. Just take note of this link here. And here's the survey from our session today. Please follow the links provided to complete today's webcast evaluation. And Michelle, it looks like you have some questions waiting there for you.
Yes, one of the questions is how you see message queuing in Vista, or really even in XP, if you don't see it under computer management, where I went through, which is what I showed you in my demo. And you probably haven't turned on MSMQ. It's a Windows feature, so you have to go to Control Panel and Programs and Features, and you have to turn on MSMQ. So it's probably just not enabled on your machine. Somebody's asking again the difference between drop queue and poison queue. Well, actually, drop is not a queue. So there's 4 features for how to handle bad messages when they've been retried and failed consistently. After the retries are complete, you can fault, which puts it back in the queue, and also faults the channel. So the service can't receive more messages on that particular service host until you fix the problem. That's the only way to get reliability that I don't lose the message in MSMQ3. If you say drop, you're saying just drop the message. After you retry 3 times, the message will just be disappeared. So you will not guarantee that you find all messages. The messages could be lost. So that's in a case where they're nice to have. I don't know any system that, wants reliability, but it's nice to have. You either want reliability or you don't. So I don't recommend drop. When you look at the other 2 options for poison or dead letter queue will automatically receive messages that time out, and it will also receive messages that you explicitly reject. So you can set the receive error handling to reject. If you want to just move it, then you can say move, and that moves it to the poison queue. And so I already in the slides showed you the difference in terms of how you access those queues. So what does the queue address look like? If you have any questions, let me know, but I also have samples for that in my download. So you might want to take a look at that. Okay, somebody's asking a question related to a previous webcast, so why don't you hang on and I'll answer that last. Net MSMQ compared to MSMQ. Well, so I think you're talking about the 2 WCF bindings. So net MSMQ binding is intended to be used for queues that you create to work with WCF. If you're using the other binding, then it's for backward compatibility with your COM+ queued components. So that's a different semantic. Okay, so I do have a question related to transactions from a previous webcast asking if the DTC on the machine for transactions needs to be enabled. Yes, that's true. By default, DTC is disabled. Yes, and in the webcast I showed you where to go to enable that. Somebody's asking, how do you painlessly enable DTC for thousands of machines without manual intervention? I think you should email me that question, because that is a much bigger question than we can answer right here. I mean, bottom line is that's probably an IT question in terms of logistics. I don't even know that there is an easy way, frankly. So if you email me offline, we can discuss that. The question is now, what if a client is down after dispatching the message? Would the messages still be delivered to the server? The answer is yes. Now, if you're talking about the client machine going down, you will already have written the message to the client machine queue. It's durable. It saves it there. Machine comes back online and then tries to replay to the server queue. If you don't actually get the message into the queue, then the client application or whoever's using it probably knows it didn't go through, so they're probably going to retry whatever they did. And if you're saying if the client application goes down, yeah, that doesn't matter as long as you've written to the queue, because then MSMQ takes over getting the message to the server. Okay, that looks like it for the questions right now.
All right. Well, if we get any more questions, we can take them via text through the Q&A manager, if that's okay. All right. Well, I do want to extend a very special thank you to you, Michelle, for your presentation today and for answering all the great questions we had come through the queue. Ladies and gentlemen, this is going to conclude today's session. I want to thank you again for joining us. You may now disconnect from the audio portion of today's presentation.